Hello everyone. Today we're diving into the essential components of computer hardware. We will be doing a quick overview so you can understand basics, and later we will explain them further in depth. Let's start with the Central Processing Unit, or CPU, often called the brain of the computer. The CPU plays a critical role in executing instructions from programs. It's responsible for performing calculations, managing data, and controlling other hardware components. So, how does the CPU work? When you open a web browser, for instance, the CPU processes all the instructions needed to launch the browser and load the web pages. It moves data between various parts of the computer, such as retrieving it from the hard drive, processing it, and then either storing the results in RAM or sending them to the display. The CPU also ensures that all hardware components are working together smoothly, coordinating activities by sending signals to memory, storage devices, and input/output devices. There are different types of CPUs. A single-core CPU has just one processing unit, which means it can handle only one task at a time. You'll mostly find these in older computers or basic devices like some smartphones and IoT gadgets. Single-core CPUs can struggle with multitasking. For example, if you try to run an antivirus scan while watching a video, the performance might slow down because the single core has to juggle both tasks. In contrast, a multi-core CPU contains two or more processing units or cores on a single chip. Each core can handle different tasks simultaneously. This is common in modern computers like desktops, laptops, and servers. Multi-core CPUs are much better at multitasking. For instance, a quad-core CPU can manage for different tasks at the same time, making your system more efficient. This means you could run video editing software, browse the internet, and listen to music all at once without noticeable lag. Let's talk about CPU performance. Clock speed is a key factor here, measured in gigahertz or GHz. 1 GHz equals 1 billion cycles per second. Higher clock speeds generally mean faster processing. So, a CPU with a clock speed of 3.5 GHz can perform more operations per second compared to a CPU with a clock speed of 2.5 GHz. Additionally, CPUs have cores and threads. Cores are the actual physical processing units on the chip, and more cores allow for better multitasking and improved performance in applications like video editing or gaming. Threads are virtual versions of these cores created through technologies like hyperthreading. More threads can enhance multitasking even further. For example, a quad-core CPU with hyperthreading can handle 8 threads simultaneously, doubling its multitasking capability. Next, let's move to memory, or RAM. RAM stands for Random Access Memory, and it acts as the computer's short-term memory. It temporarily stores data that the CPU needs to access quickly, like data from currently running applications and open files. RAM is crucial because it allows for quick access to data, which is important for running multiple applications at the same time and handling large files, such as in photo editing or database management. There are different types of RAM. DDR, or double data rate, is the most common type used in modern computers. Each generation improves in speed and efficiency. DDR3 was used in computers from around 2010 to 2015. DDR4 is the current standard and offers better speeds and energy efficiency. DDR5 is the latest generation, offering even higher speeds and efficiency, and is becoming available in high-performance systems. Another type is SRAM, or static RAM. SRAM is faster and more expensive than DDR-RAM and is used in smaller quantities for cache memory, usually within the CPU itself because it's faster and doesn't need constant refreshing like DDR-RAM. Having more RAM allows for smoother multitasking. For example, a computer with 8 GB of RAM will handle multiple applications better than one with 4 GB. Faster RAM also improves data access times, which enhances overall performance, especially in data-heavy tasks like gaming or video editing. Now, let's look at storage devices, starting with hard disk drives or HD disks. HD disks use spinning magnetic disks to read and write data. They're cost-effective and offer large storage capacities, making them great for storing large amounts of data like media collections and backups. However, they have slower read-write speeds, which can lead to longer boot times and slower application loading. They're also more susceptible to physical damage due to their moving parts. On the other hand, solid-state drives or SS disks use flash memory with no moving parts. They provide much faster data access and boot times. For example, an SSD can boot an operating system in seconds compared to minutes for an HDD. SS disks are more durable because they lack moving parts, which makes them ideal for laptops and portable devices. They also consume less power, which benefits battery life in laptops. However, SS disks are typically more expensive per gigabyte than HD disks, although prices are gradually decreasing. Comparing the two, SS disks offer superior performance and durability, making them ideal for operating systems and applications that require fast access. They can dramatically speed up tasks like opening programs and transferring data. SS disks are commonly used in modern laptops and desktops, especially for boot drives and applications, while HD disks are often used for additional storage due to their cost-effectiveness for bulk storage needs. Finally, let's discuss the motherboard, the main circuit board in a computer that connects all components and allows them to communicate. The motherboard integrates the CPU, RAM, storage devices, and peripherals, facilitating communication and power distribution. It manages data flow between the CPU, memory, storage, and other components, ensuring that when you open a file, data moves from storage to RAM and then to the CPU for processing. Key components of the motherboard include the chipset, expansion slots, and various connectors and ports. The chipset controls data flow between the CPU, memory, and peripherals. It includes the North Bridge, which handles high-speed communication with the CPU, RAM, and graphics, and the South Bridge, which manages slower connections like USB, Ethernet, and audio. Expansion slots allow you to add additional cards for enhanced functionalities, such as high-performance graphics cards or network cards. Connectors and ports include USB for peripherals like keyboards and printers, HDMI for monitors and projectors, and Ethernet for wired internet connections, which provide faster and more reliable network connectivity compared to wireless. Motherboards come in various form factors. ATX is the standard size for most desktop motherboards, offering the most features and expansion options. Micro ATX is smaller and suitable for compact builds with fewer expansion slots, while Mini ITX is even smaller, ideal for very compact systems but with limited expansion capabilities. Ensuring compatibility between the motherboard and other components is crucial. For instance, CPU sockets need to match the CPU type, such as Intel's LGA or AMD's AM for sockets. RAM compatibility is also important, ensuring the motherboard supports the type and amount of RAM you plan to use. That wraps up our overview of computer hardware components. Thanks for joining, and let's move on to the next topic.